Okay, so I'm set up here for the second review video. This one's all about trigonometry. This is going to cover right triangles, non-right triangles, sine law, cosine law, um, plotting a point on the grid and turning that into a right triangle. Um, so that one we haven't done for a little while, so that's going to be a good refresher. A little reminder at the beginning of this note or this review page that says, please remember to have your calculator in degree mode. So there are a couple of times throughout this course where I've had people saying in the chat in our lessons that you typed it in properly, you've tried it a bunch of times, and you're getting the wrong answer. And usually that's because your calculator has changed itself to radian mode. So we're going to be looking on our calculators to make sure that it says D or maybe DEG, depending on your calculator display. So it needs to say one of those things, and there's going to be a mode button that will help you switch between the different angle measurements. So just a little warning right at the start there. We need our calculators to be in the proper units. Okay, so question one, determine the unknowns. In each of these pictures, there's an X marked somewhere that we're going to solve for. And the first one here is a right triangle. So since it's a right triangle, we can use our right triangle tools, which include Pythagorean theorem, and we can also use SOHCAHTOA. So in order to use SOHCAHTOA, that's the one that uses angles, and I do see an angle given here, marked up at the top. And across the triangle from that marked angle, or the given angle, is the opposite side. This side would be called the adjacent side, the one that's touching the angle, and the hypotenuse is the other one. Okay, so we start out by labeling the names of the sides just to make sure we don't mix them up in the wrong order. And then since we have a right triangle, we can use SOHCAHTOA as a tool to help us figure out which trig ratio we should be using, sine, cos, or tan. So in this particular triangle, the opposite is where our unknown is. So the opposite is of interest, and the hypotenuse is given. So if I take a look at SOHCAHTOA, the one that has two check marks is the sine, the so part of that. So we're going to be making a sine equation for 25 degrees, which is the given angle. So I looked to see which trig ratio, sine, cos, or tan, which one had two check marks. Okay, so sine of 25 degrees is opposite x over hypotenuse 10, and I'm going to be solving that one for x. X is being divided by 10. I want to get rid of that, so I'm going to multiply both sides by 10. And I'll be left with 10 times sine 25 degrees equals x. I'm going to pop that right into my calculator. I don't need to find sine of 25 as a separate answer. I can just do it all at once, and I'm getting 4.2 as my calculator answer. And looking at the triangle, I see that the measurements are in centimeters. All right, so anything that has to do with measurements, whether it's our like surface area and volume in the last video or with trigonometry here, anything that has units involved in the problem, like we need to make sure we include units at the end so that the answer makes some kind of physical sense. Okay, next one is a non-right triangle. It is not a right triangle. So here we can't use SOHCAHTOA, we can't use Pythagorean theorem, but we have sine law and cosine law as tools at our disposal. So to start with, I'm looking to see where the unknown is. That's over here in the bottom right is where the angle x is marked. So I'm going to attach labels to here, the A, B, and C, and the order doesn't really matter as long as the capital angle is across from the same letter in lowercase form across the triangle. I'm going to call this one at the top A, and across from that will be the lowercase a. And this last one will be called capital B, and across from it will be little b, lowercase b. So all that matters is that they match each other across the triangle. With those labeled on there, I can look at this and try to decide, is this a sine law question with the opposite pair that is given, or is this a cosine law question where there was that side angle side pattern? So here I see an opposite pair that's complete, an angle and its opposite side. So this is going to be a sine law problem using the a's and the c's, since that's where my variable is. So angle C is the one I'm going to be solving for. So with the sine law, I'm going to choose to put the variable that I'm solving for in the top left of my equation. I'm putting angles in the numerator since I'm solving for an angle, and the lengths in the denominator. And I went even farther and put the one that I want in the top left, just because I like that. We can start plugging in the stuff that we know and leaving whatever we don't know, like angle C, leave that as a variable. If you want, you can swap that out for the x in the diagram. Across from that sine A will be sine of 80 degrees. And the side that goes with that is 20. So we're trying to find x. I got to get rid of this 14. So I'll kick it out of there using multiplication. 14 multiplied by sine of 80 degrees divided by 20. So you can choose if you want the fraction to continue the whole way or not. You will get the same answer either way. So you just decide your own comfort with how it's shown. All right, sine x is equal to 0.6894. So that's from multiplying 14 times sine of 80 degrees divided by 20. And to find this mystery angle, we need to use inverse sine to get rid of sine. And it should come out to 44 degrees. So that one ended up taking me a lot of space. I'm writing with my big pen this time. But that was a sine law approach because of the opposite pair that was given in the question. That was a perfect setup for sine law. All right, the last triangle on this page has the Pac-Man shape. So two side lengths with known lengths and the known angle right in between them. So Pac-Man's eating the 35-degree angle. With this triangle, we're going to be using a cosine law setup. So again, we just have to start by naming the angles and the sides so that we can match it to the cosine law formula. I'm going to pick A for my solving variable. So the angle is A, across from that is lowercase a. B and C, doesn't really matter where they go, but I'll pick the same as last time. C, C, and that makes this little b. Okay, so I've labeled the side lengths with lowercase and the angles with uppercase letters. And from there, we can grab a cosine law equation that's going to use angle A to solve for the unknown side A. So cosine law, I always write the formula out first. I did that here as well, so I recommend you do that. We're solving for lowercase a. In the given diagram, it was actually an x, so I'm going to swap that out. Lowercase b is 10. Lowercase c is 12. And cosine of 35 degrees. Okay, so this right-hand side, it's possible to do this all in your calculator at once, especially if you're using the Desmos scientific calculator. It's got a nice display and lets you like match the format exactly. And your answer from your calculator should say 47.4. It's not quite what we're looking for because this is x squared. So I'm going to take the square of both sides, sorry, square root of both sides to come up with my final answer, which is 6.9. And in that picture, the units were centimeters. Okay, so there's a right triangle, a sine law, and a cosine law. So the three major types, or like tools or strategies that we've used throughout the course. All right, number 2, determine the angle of elevation. Angle of elevation to the top of a 100-meter tall building if you're standing 125 meters away from the base. Include a labeled diagram as part of your solution. Okay, so I have a tall building. I'm going to put it over on the right side of my page this time. It says I'm standing 125 meters away. So this is 100 meters. This is 125 meters. My diagram is huge for some reason. You don't need to make your triangle as large as this. But it says find the angle of elevation. So we want the angle down in the bottom corner. So if you're standing here with your eyes looking up, how steeply do you have to tilt your eyes up? So here's the building. Okay, so in this diagram, I can see that there's a right triangle. I marked it there kind of automatically because I know that buildings are vertical and the ground is usually horizontal. And those are 90 degrees from each other. So this I have my known angle on the bottom. This side is going to be the adjacent one. This side is going to be the opposite one, way across the triangle. Opposite and adjacent are part of the tan ratio, or TOA. So I can make a tan equation. I don't actually know the angle, so I have to leave an x in my formula. But the ratio is opposite, which is 100, over adjacent, which is 125. 100 over 125 is 0.8. And then I want x by itself, so I have to get rid of tan. Tan inverse is the way to do that. So I can do the tan inverse to the left and the tan disappears. I do tan inverse to the right and I need a calculator. And my answer there is approximately 39 degrees. All right, next one is a kind of different feel to it. It doesn't ask you to draw a picture or anything, but it does say show work. So it says, given that sine has this answer, determine all the possible values of cosine of x. Sine of x equals this, cos of x equals who knows. So that's what we're going to try to find. So sine x is 0.6157. I can find the angle x, just like in the last question. I can find the unknown angle, and that's really all I can do with this equation. Right? I can't rearrange it. There's no diagram. So I'm just going to get x by itself, do sine inverse of both sides. Sine inverse 0.6157, and that comes to around 38 degrees. So my angle, my unknown angle is 38 degrees. And this is find all the possible values of x, of cosine of x, which implies that there might be more than one. So what this is referring to is the quadrant 1 and quadrant 2 triangles. So quadrant 1, here's 38 degrees, drawn in quadrant 1. If I draw a 38-degree triangle in quadrant 2, they're not the same. There is like a way of distinguishing them, and that is by starting at the x-axis and counting our angle measurement from there. Okay, so this first one I would call 38 degrees, but this second one, I'm turning way more than 38 degrees to get to that spot. So my answer, my second answer is going to be not a full 180, but 180 take away 38 degrees. And that's 142. Okay, so the trick for this one, it said all possible values, is that that sign can be positive in quadrant 1 and quadrant 2. So I'm going to draw like a copy, a flipped copy of the triangle in quadrant 2. All right, so my red angle is 38 degrees, my green angle is 142 degrees, and we're going to find cosine for both of those. Cosine of 142 is negative 0.7880, and my red angle, 38 degrees, cosine of 38 is positive 0.7880. Okay, so that was, I think, back in cycle 3, when we did quadrant 1 and quadrant 2. Oh no, that was cycle 2. Quadrant 1 and quadrant 2. We even did ones where we plotted a point somewhere and made a right triangle by connecting it to the origin. So we'll see that come up on the next slide. But what we learned in that, like that whole process, was that sine is positive in both of these quadrants. Like opposite is positive. The hypotenuse has a positive length, so a positive number divided by a positive number gives a positive value for sine. That's not true for cosine. Cosine is positive in quadrant 1 because the adjacent side is positive and so is the hypotenuse. But in quadrant 2, the adjacent side is negative. It's off to the left, which makes the cosine answer negative in quadrant 2. Same number, but a negative sign tacked in the front. All right, so we're nearly done our trig review. The very last question is kind of similar to the previous one. And I mentioned this a second ago. And this is the kind where you're told a point, just a point that you're going to plot. Plot the point. So 4 over 3 up, 1, 2, 3, and plot a point there. And it says that this point lies on the terminal arm. That's a little bit of vocabulary. It lies on the terminal arm of an angle in standard position. So standard position, remember, implying that we're going to start at the positive x-axis and rotate counterclockwise from there. So here's the point 4, 3. The terminal arm, we swing it around to like wherever we want in the full circle, but here it's landed with coordinates 4, 3. And we're going to fully label this. So we've got a little bit more to add to this diagram. So the terminal arm is the hypotenuse. I've marked off a right triangle by dropping a vertical line from the point to the x-axis and then using the x-axis as the other side. This is a right triangle. And the side length, we actually know the side length. This is 4 units over because x is 4. This side length is 3 because the point here is at y equals 3. And we can figure out the hypotenuse, and maybe you remember that we were calling it r back in cycle 2. So I don't know that length yet, but we can find it using Pythagorean theorem. a squared plus b squared equals c squared, or the reverse, c squared equals a squared plus b squared. And I am actually going to flip it here to get the radius by itself. And then a squared plus b squared. I'm just using the two perpendicular lengths. Order doesn't matter. Working my way through Pythagorean theorem, we're going to have to square root both sides. The radius is 5. So I found this number out. I can add it to my sketch. And this is pretty well labeled already. The only things I might add are the fact that the angle, the important angle in this triangle, is tucked into this little corner, which is hard to draw in. And we can also label things like adjacent, opposite, and hypotenuse in case SOHCAHTOA strategies come into play. Okay, I'm getting rid of some of the extra stuff. All right, 2 more little questions that follow from this one. Complete the triangle on your sketch. So I did that in purple. And use the triangle to determine the ratio for sine theta. So sine of this angle down in the bottom left corner in lowest terms. So if we can reduce it, we should. Sine is opposite over hypotenuse from SOHCAHTOA. Opposite over hypotenuse. The opposite side is 3. The hypotenuse is 5. So sine theta is equal to 3 over 5. That is in lowest terms. It can't be reduced any farther. Our very last trig review question. It says use your calculator and your answer to part B to determine the measure of angle theta. So from part B, we found that sine theta is 3 over 5. 3 over 5 is also equal to 0.6 if you prefer decimals. And in this equation, theta is the unknown that we're trying to find, the angle theta. So I want to get rid of sine. I'm going to use inverse sine to get rid of that. Inverse sine of 0.6. And that answer comes out to around 37 degrees. Okay, so there is our full review for the day. Measurements and conversions and geometry stuff in the first video. And here was all things trig.